Hi everyone, and welcome to this YouTube channel. My name is Penny, and this is Penny's Coding Bits. Before we start, I must apologize because I haven't been updating this channel for the past few weeks because I got sick and lost my voice. So if anything is unclear in this video, please bear with me. So in this video, we are going to walk through this RShiny app that converts this piece of text that a user inputs into this user input box into this relationship diagram that you see on the right-hand side between the nouns that the app detects in this text. And this is based on a blog that I had written in Python last year. And the knowledge graph looked something like this back then. So let's have a closer look at this RShiny app. So first of all, let's have a look at the piece of text that's used to test out this app. And this is mainly about the solar system. And the first paragraph is about the solar system in general. And the second one is diving more deeper into the objects that orbits the sun. And the third paragraph is more into the small and larger planets that's orbiting the sun. And finally, we are giving more information about the age of the solar system. So let's see how this relationship chart is capturing these information. So first of all, at the center of this relationship chart, it detects the solar system. The solar system is pointing to solar, so it's the solar system. It's the gravitational bound system of the sun, and the objects that orbits it, either directly or indirectly. So the solar system is the gravitational bound system of the sun. The sun is right here. And the objects that orbits the sun. So you see a lot of arrows back and forth between the object and the sun. So that's how the app is picking up the relationship between the objects and the sun. And of the objects that orbits the sun directly, the largest are the 8 planets, with the remainder being smaller objects, such as the 5 dwarf planets. That includes Pluto, Eris, Haumea, Makemake, Ceres, and small solar system bodies. So first of all, we can see that Pluto is right here, and we see that it picks up the remainder planets is here, and the 8 largest planets are being identified here. So they are all interconnected, the 8 largest planets and the remainder smaller planets. And the smaller planets are being pointed to Pluto, Eris, Haumea, Makemake, Ceres. And as we move down to the next paragraph, we are starting in a different section of the graph. And the next paragraph says the largest planet is Jupiter. So Jupiter is here, followed by Saturn, Uranus, Neptune, and the inner planets are Mercury, Venus, Earth, and Mars. And we see that there is the moon that's here and Luna. So you see a to and from arrow between Luna and the moon because they are one in the same. And we see that what the system is picking up in the last sentence of this text chunk is the solar system is from the gravitational collapse of a giant interstellar molecular cloud. So I'm not really satisfied with how much information is being extracted from this last sentence because it's only picking up it's from a collapse of a cloud, where there should be much more information. But I guess all of the other information in here are not nouns. So they are not entities to be picked up. So now that you have had a look at how this app is working in the front end, let's just have a quick walkthrough in the back end. So this is the back end of the R Shiny app for building out the relationship visualization from text. So at the top, you see that there are 4 libraries in this app. The first one is the Shiny library that supports the overall setup of the R Shiny app. And the second one is UDPipe, which is a natural language processing library within R Shiny. And iGraph is for creating and manipulating graphs within R. And last but not least, Viz Network library is for creating network visualizations within R. And before we dive into how to analyze the text from user input, we need to download the UDPipe library for English. And that's what this UDPipe download model does. And once we have it downloaded, we need to load it into a object called UD model so that we can use it down here to annotate the text that's inputted by the user. And once we have it annotated, we need to extract out the nouns and the proper nouns. So proper nouns are specific people, organizations, or places. So if I call George, that's a proper noun, with a capitalization of the first letter. So nouns and proper nouns are all being extracted in this piece of code here. And we need to check if there is any nouns found. Sometimes there may not be nouns in a piece of text. And we need to, at this point, create a data frame with the required columns for edges. So this is where we place the nouns into the nodes in our visualization and create these arrows that tells us what their relationships are. And you could do this if you want to change or reposition your nodes in this visualization. So the way we extract the information that identify these arrow relationships is we need to extract out all the nouns in a sentence. So here we have a sentence that says the solar system is the gravitationally bound system of the sun and the objects that orbits it. So the from column extracts all the nouns in order in this entire sentence minus the last noun in the sentence. And the to column extracts all the nouns in order in the sentence except the first noun. So if you place all of these nouns in a pairwise sequence, so I'll say system and sun and object, because these are the 3 nouns in this sentence, the from column would extract all the nouns except the last one. So we're left with system and sun. And the to column is all the nouns except for the first one. So we are left with sun and objects. And if we place them in this pairwise setup, we are left with the first noun being connected to the second noun, and the second noun is being connected to the next noun, and until we reach the last noun in the sentence. So you see that system is being connected to the sun, and the sun is being connected to the object. So that's what this code chunk is doing here. And this is the core of how we are identifying relationships between nouns in this app. And I guess you could call this a simple way of identifying relationships in text. And of course, there are more advanced text mining methodologies for visualizing relationships in text, much like this. But this is a very simple way of identifying relationships between nouns in a sentence. So once we have this pairwise sequence identified, we can create a data frame with the unique nodes that's within this pairwise system. So if there are duplicates, we get rid of them. So you see that there are unique commands for each of the to and from columns that we have identified above. And last but not least, we return the nodes and the edges from the above functions. And then we have the user interface setup. And so you see the title panel and the sidebar and the main panel that contains the final network plot. And the network plot is being made possible by these visualization codes here. So this is observing for the input text being inputted into the user input box. And we're calling the extract nouns chunk that we have identified above here. And once we have the nouns extracted, we are checking if they are successfully extracted, and we generate the plot. So I hope this can come in useful for some of your text mining exercises, and I'll see you in the next video.